My name is Marian Marinov. I'm the Director of Engineering at Web Hosting Canada, and today we will be discussing LXD and why we should choose that. I have a microphone here because we are doing a recording of this. So if anybody has questions, I'm just going to throw this like that. Yeah, you usually have to catch it. It's not a problem, and you can speak on it. Antonio would turn it on.
Do you want to try? Yeah, this sounds like a disaster if I get coffee.
Don't worry, don't worry.
You have your question and that's it. Oh, just turn on and allocate it.
All right. So, before I continue, we would explain a little bit what LXD is and why we should consider it, and its open source version now, Incas. So I created a page where all of this is written, so you would see a lot of nodes here and a lot of links. You don't need to remember any of this. This is already available online on a web page, lxd.1h.cx. And I also grant you access to 4 nodes, so you can just connect to them with this root password. And I suggest while I'm speaking, you log in there and add your public key to these 4 nodes so we can work on these machines together, okay? And yeah, this page is on lxd.1h.cx, no numbers. So lxd.1h.cx. Okay. So while you're writing this, I'll explain why LXD. I have built clouds for many companies, and personally, I have tested different clouds myself, different cloud architectures, different provisioning systems. And for me, LXD is just a simple thing that is not also limiting me in what me as a system administrator can do. The important thing here is that if you decide to choose anything else, usually you have to abide by the rules of that specific thing. So if you decide to go with Kubernetes, OpenStack, OpenShift, Docker, whatever you choose there, you do not have a lot of freedom. You have to do a lot of the stuff only the way the system is offering you. What LXD does is, for me, this was the first implementation of real containers, and I'll explain why. So containers in Linux in the kernel, not the operating system, not the software that is there, but the kernel is not a first-class citizen, as we call it. So essentially, we don't have a container. Depending on who you ask, container may be just a few control groups or a few namespaces. LXC, so Linux containers, LXC was the first thing that started combining all of these together in building one entity. And that one entity was a thing, a process that had its own namespaces, control groups to limit resources, and everything was rooted in a different part of the file system. So this process now can run whatever you want there. And this is how we ended up with a container. Later on, other technologies started popping up, but because LXC was so closely built around the kernel and what was introduced in the kernel, it was actually the reference technology for most of the new stuff that was entering in the kernel. So this means that it allows you to do all the stuff that you want with the kernel, and you're not limited in terms of infrastructure. The next thing is LXC was only running containers, starting the containers on your local machine, and its API was not the best. And the same authors that created LXC created LXD. So these guys decided to do a wrapper around LXC and essentially create something that would manage multiple containers. And what happened is also that it is now also managing virtual machines. Actually, all of these 4 nodes that you would connect to are virtual machines started from LXC, and I'll show you this a little bit later. So before we continue, what you're seeing here is a diagram of the server where these things live. It's called Gandalf. And we have currently a few machines already there with private network, 10.2.3, 1.2.3.4, and so on. And with public addresses for each machine there. You can connect to any of the public addresses, no problem. If anything breaks, just raise your hand, we'll fix it. We have access to the host node and to the network, so it shouldn't be a problem. Currently, what we are seeing is that all of these machines are bridged on a single switch, a single bridge inside Gandalf. And Gandalf is .20, which is the LXD.1H.cx. These machines and the machines that we have created for this training, for this workshop, and for these exercises, they would remain after this workshop for at least a month. So don't worry, you would be able to play with them even in your home. Okay? Now, so before we dive into this workshop, what's the difference between a virtual machine and a container? So for me, the main thing here, I'm not going to delve into the actual differences. What I'm going to say is, with virtual machines, you get a lot of abstractions, you get a lot of limitations in terms of how you can use your resources. Things like adding memory require most of the time cooperation from the VM itself, and having additional kernels, you're getting with abstractions there where these abstractions are creating more problems for you in the future. It may be performance, it may be resource limitations. When you have containers, you have processes running within the same kernel. The important thing there is now, because you're running within the same kernel as the host node, you're opening the door to a significantly bigger attack surface, which means that whenever you're playing with containers, there is always the possibility of getting out of that container. Obviously, this is not a common situation. This is why we have the containers, right? But 0 days appear from time to time that may actually go back to the host. So security-sensitive software, probably best not to be run by containers. It doesn't really matter if it is LXD, Kubernetes, or whatever. I just want to point this out. Okay. What options do we have for containers? Again, this is an HTML page that would live on later on, so I'll just skip through some of the text here, and I'll just explain a few things. I have linked directly other options that you can have instead of using LXD. You can run Kubernetes. You can decide, okay, on my machine or on my server at home, I would run microkube, not the full Kubernetes, because it's too much of a hassle to deal with. Then you can say, okay, I'll go with HashiCorp Nomad because it's easy, it's significantly easier than the rest of the things that are on this line there. If you go OpenShift or OpenStack, I would put OpenShift, OpenStack, and Kubernetes at one level of complexity. These are increasing your complexity significantly. Sometimes you even need specific person that have been certified to work with these technologies only to set up this for you. So having that on your local laptop or office machine is not that easy, and it generally takes a lot of more effort to set up that. You may go with Proxmox, which after Broadcom did their fiasco, is now gaining a lot of traction. I want to point out that Proxmox is not using LXD, it's using pure LXC containers, which means that the configuration is under certain control within Proxmox, and you cannot easily change a lot of things the way you would want to. Containerd and Podman are the two things that are probably most on par in terms of complexity to what LXD is proposing. And if you don't want to have a very big orchestration, you can just go with pure LXC. So you would just run your containers. You can go with Docker or even small things like runc or RKT. Keep in mind, RKT is generally not supported since 2 or 3 years. So if you go there, you're on your own, but it's still working for whatever it is providing. Now, today we would be discussing LXD and Incus. LXD was initially an open source project. This year, however, Canonical decided to change the licensing, which immediately prompted the authors to create a fork, and Incus is this fork. So they were on par in terms of functionality until probably February this year, but now they are already different in terms of what they are offering. So Incus is moving forward with a lot more features right now. Essentially, the team that created LXD forked and continued developing that into Incus. So why would you choose LXD instead of LXC? Because simply, if you want proprietary support, you would go with Canonical, and Canonical would offer you LXD. But if you want community support, the community is generally not very happy with what Ubuntu did. So if you are running LXD, there would be support, but not that much. And people won't be very happy, may ask you to upgrade to Incus. So that's it. Again, why you should choose to start setting up LXD, because it's simple, and you would see how simple it is, and because it's still very powerful compared to the rest of the bunch. Okay, and yeah, the last thing that I missed is LXD provides you with a very nice API that you can use to generally orchestrate your infrastructure. So as soon as you have created your local setup, you can just start talking to it over API and forget about it. Now, a few things that we need to discuss is first, on which distributions should we run this. The authors of LXD are Ubuntu guys. So they developed this on Ubuntu, and they also develop on Debian. So one of those two should be your main choice. There are options for other distributions, but one noticeable thing is that there are no options for CentOS Alma Linux. So the Red Hat guys are not represented here, and you're generally Debian, Ubuntu, Devuan, these distributions. There are versions for Gentoo, if I remember, and other distributions that I did not know existed. But yeah. Now, I told you about LXD vs Incus, cluster or standalone. you can start easily with standalone instance on one server, and you should switch to cluster only if you actually need the cluster infrastructure. You can, even without a cluster, you can simply migrate or copy a container from one machine to another without a big problem. Now, the next thing is storage considerations. As LXD supports many things out of the box, you would be thinking, okay, should I go with directory storage, BTRFS, LVM, LVM cluster, or ZFS or Ceph? But as I said, you can actually tune this significantly by simply designing the storage yourself, like, for example, create a nice cozy interfaces that are then on top of them you have LVM, and that LVM is then exposed to LXD, or you can decide to use a distributed file systems like OrangeFS or BGFS or something like that, where you would provide your mount points to LXD and it would manage that for you. Or you can even say, okay, I would not be giving LXD the control over my storage. And this is important because most of the other systems that you would know, they are not allowing you to just do whatever you want on the storage. It's whatever that system is providing you. With LXD, that's not the case. Obviously, it's not integrated directly in the interface, which means that you have to do all the work, but you're allowed to do that. And I'm very happy because in my home setup, and all of this is actually at home right now. So in my home setup, I have very strange storages actually exposed to my machines, which means that if I am limited to only one storage system, I won't be able to leverage all of this storage that I have at home. So next thing, which file system or which storage solution should we choose? There is a link to the storage solutions here from LXD. Okay, I think I opened it. Yep. So there is a comparison table here. The two things that I want you to focus here are storage snapshots, because if you want fast backups, you would need snapshots. Okay. And the other thing that I would like you to focus on is if you need any encryption, because then if you want to encrypt your volumes that you're giving to LXD, you want something that supports that. Other than that, you can clearly choose your own daemon here. If you decide to go ZFS, however, I would say that it is extremely important for you to go Ubuntu for your operating system. If you decide to build LXD on top of, for example, Debian or any other distribution, with ZFS, you have the problem that these distributions are porting OpenZFS to this distribution. It's not native to this distribution, which means that there are problems and sometimes performance issues. So I urge you, if you decide to go ZFS, go Ubuntu, because they're currently the best at integrating ZFS into the kernel generally in the distributions. Okay. So that's for ZFS. For everything else, you can just consult that table that I provided to you. Networking. Now, LXD actually allows you to do whatever you want with the networking, even not dealing with the networking, the same as with storage. And I particularly like this because I don't necessarily like the way the network is set up automatically with LXD, and I do have network provisioning for my home infrastructure. So this means that if it tries to do something on my network, it is actually overlapping and disturbing my other functionalities at home. So what options do you have? Mainly, it's MAC-VTAP and Bridge that you should consider. The differences between those: with MAC-VTAP, if you want isolation of the network traffic from your container to the world, you should go with MAC-VTAP, because with this driver, the host node do not have access to the traffic that is going through the pipe to the network. The host node itself doesn't have direct access to this data. Very nice. If you don't want isolation and want things like, I want a firewall to put in front every container that I have. Sorry. So let's look at this. If we have MAC-VTAP situation, this would mean that we don't have this bridge. And this directly links to our Ethernet driver on the host machine, and traffic is going out and in directly to the container without the host seeing that traffic. Unfortunately, this is also very annoying to troubleshoot, because on the host node, you don't see that traffic. So there are issues. It's good for isolation, but on the other side, you cannot impose any good limits on the networking, and also you cannot impose any filtering. On the other side, if you choose to go bridging, you essentially can put a firewall before the bridge and firewall whatever you want on these containers, which is nice if you have infrastructure there that you want to be protected, like, for example, dev environments for your applications. You can put one firewall here, and you would not care if any of the developers have broken anything on the firewall on their instances. You know that you have protected these instances, and there is no problem moving forward. Okay. Can I use virtual machines? As I said, yes. These 4 virtual machines that I have created, they are from they're deployed with LXD. Okay, any questions? Because the next thing is we're starting the actual commands, and I'm opening the terminals, and we're moving forward with this. And whoever wants can just SSH in and start playing with these things. Questions? Okay. Then let's dig in. The page I have created has these blue buttons here. You just copy that. When you click it, it copies the text before that in your clipboard, so you can just paste these commands directly on the servers. Okay? And before I open this, important things. So LXD1 and LXD2 have Incus already installed. LXD3 and LXD4 doesn't have Incus installed. And LXD5 I created just before this presentation, so it doesn't have anything, including networking. We'll set up that. And LXD6 we'll create just for example, from the host machine. So this is the host machine. Oh, bugger. Okay. So you would notice that I'm using the LXC command, while here we have the Incus command. In my case, the host node is actually running LXD, because it was installed a long time ago. Now, I would need actually to zoom out here. So let's see if this would do the trick. Yes. Okay. Okay. So here we have the 4 LXDs running, 5 without networking, 6 not installed. at all. What you can see, these are virtual machines, and I have some containers here where I'm testing different things. Okay? So with that in mind, now let's just make it a little bit better here. Okay. So as I said, we don't have Incus installed on LXD3 and LXD4, so I would log into LXD3, and here I am on LXD3. I can.
Sorry, I was installing it on LXD3. So.
Oh, yeah, I'll install it on LXD4. LXD4. Oh, yeah. So what you would notice is we have an Incus process here, but we don't have Incus installed here. What's this? When you're running virtual machines, in order to enter in those virtual machines, you need to have an agent. This is similar to any other virtual systems that you have used. So this is the agent, and it is injected during installation of your operating system, actually during the creation of the images for your virtual machines. So when you create these virtual machines, they actually have the agent directly there. Why is this important? Because after you start your container, you can always enter into the namespace, but when you start your virtual machine, you cannot simply go into the kernel of the virtual machine and say, start a new process for me and connect it to the host machine. So this is where the agent comes in, and it exposes a terminal to an interface, not a terminal, to the host node. Okay, so we'll go and just go through the instructions here. I found that this tutorial is the easiest thing that you can do for setting up. So first we need to add a repository. So before that, we need to create the keyrings. If they are not created, it's possible that on this machine it's already created, but nonetheless, I'll paste the command and execute here. Then we'll need the key. We'll execute that. Okay, so the key is now added to our Zabli file. Then we need to add the repository. Yeah. And here we go. Okay. Now that we have the repository, the two things that we need to do is update and install. So to get the list of packages from the new repository, and as simple as that, apt-get install incus. Yeah, you would notice I'm not using apt. Okay, now this is installed on the machine. The next thing that we need to do is initialize it. This is the most important part, where we would actually do the setup of how we want our LXD to be configured, Incus to be configured on our machine. So the first thing is...
You can jump on tree. I'm stuck at that new
Okay. You're stuck on it?
Well, it's been running for a while, and okay, now it's just resolved. Never mind. But it took like a good 3 minutes to.
Yeah.
Actually prompt something.
We'll see that. Okay. So incus admin init. Okay. Why is it waiting for so long?
You're gonna need a bit 4-minute filler here.
Whoa! It did not.
How to dance or
It did not take that much time before, but again, for a demo, it's always broken, right? So let's see. Yeah, LXD. Okay. Just to be sure we have resolving. Okay. So in this case, yeah, I want to see. Yeah. Before we started, I added 100 gigabytes to each of the VMs. And yeah, that is unfortunate because now it actually doesn't know about this device. And the kernel is waiting on this because I didn't reboot the virtual machines. With virtual machines, storage is a little bit difficult. Okay, that specific one, PV create SDB. Yeah. Okay. Well,
if you switch to LXD3 and just cancel the admin, I should run super fast.
okay. Let's see. It's already started. So. Yeah. One strange thing that most people don't understand about Incus is that when you start it, it's actually asynchronous. You start the daemon, you send the command, and the thing that you are waiting on here on the terminal is a response from your asynchronous command. So you have already executed this. It has done something. Okay. So the first setup that we would do is without clustering, so default 0. Then do want to configure a storage pool. Again, this is LXD4. And yes, I want to create a storage pool. This is exactly why I added those 100 gigabytes to this instance. What would be my storage pool name? Let's say store1. Just to not be default to see this. And I want LVM. Okay, and then create a new LVM pool. Yes, we want a new LVM pool. And would you like to use an existing empty block device? Well, yes. Okay, the FSDB. Yes, we want that. Now, this is for the networking. So the first things, again, clustering. This is a little bit misleading, but the important question here should actually have been, should we expose this instance to the internet, to the network? Saying no here does not expose this to the network, which is the thing that I suggest you do, guys. Then if ever you want to make it a cluster, you can do that later on. It's not a big deal. So the next thing, the storage pool. As I told you, it allows you to do things that other systems won't allow you. So here we chose LVM. But let's say I want LVM, but I also want LVM with tin pool. And that tin pool is already created because it was already attached to a different machine, and now I'm moving the storage to this machine here. There's a problem. We cannot ask here Incus to create a new pool over our existing pool. It would actually delete it. I have done so in the past. Don't do it. It's not good. So here I have decided to choose to create a new storage pool. I also told it that it would be on def SDB, which is the device that I have added to this VM. And with this, we are done with the storage. There are no other questions right now. The next thing is the network. Again, if we were guided through this setup, then we should, if we want to be guided through this setup, we should just read through the questions and execute whatever we want. In this case, I want to create a new bridge for my containers here. What would be the name of that bridge? Before it was called LXD BR0. I generally don't like typing that much, so BR0 is enough for me. And the next thing, IP addresses. You can either do manual or none, or you can do the auto. Here we will leave the auto for IPv6 too. And no, we don't want it over the network. And now we have a few performance questions. Should we have a stale cache updated? By style cache here, we are talking about the images that you have downloaded to set up new containers. Let's say that we would set up Ubuntu 2022, and next year we want to set up new containers, but with Ubuntu 24. That's fine, but again with Ubuntu 22, but in year 2024. If you have set up in 2 years ago, you would still have images from 2 years ago which do not have security updates, which means that as soon as you create your container, when you run the apt-get upgrade, you would get a lot more updates and to work on. What this allows you to do is simply to update on the background these images, so whenever you set up a new container, it's always with the latest version of the distribution that you have selected. And then do you want the configuration printed? We will not read the YAML, okay? That should be enough for us to finish our setup here with incus. So the next thing that most of us would do is set up a new container. But before setting up a new container, what can we set up, right? What operating system? If this is a virtual machine, usually you have to prepare an ISO that you would mount to your virtual CD so you can install this. With LXD, with incus, that's not a problem at all. You simply go here and incus list images. Yeah, it's this command. Not this, this.
Remove the 2 dots.
Image. Wait.
You have this thing if you're on the one.
LXD 1H6. Okay. LXC image list images. Yeah, I have them here. Wait, don't worry. I probably haven't refreshed these. Yes. Yeah, resolver. It's DNS, you know. So we have here a lot of images. Generally, if you go to the LXC, oh, I forgot to link it here. I'll link here from the documentation where you can find the list of all images available from LXD. That these are community-driven images, so they're already prepared for you. You have everything. You have CentOS, you have Alma Linux, you have even Slackware, you have Debian, Ubuntu, Gentoo, Arc, whatever you think of, most likely you have it there. I believe there are more than 100 images already available, so you can list whatever you want. And let's say that we want a Debian here. So I'll just choose any of these here. And now the important thing is architecture. If you're not running on this architecture, you may have problems. So I suggest that you're focusing on your architecture. And in this case, that would be x86 for us on this machine, right? What was this? Yeah, this is an Intel. Okay, so here, 2 important things. First is the type of the image. One is for virtual machine, another is for container. So you may have Debian 11 and Debian 11 Cloud. These are two different things. In this case, this is the container Debian 11, and this is the virtual machine Debian 11. Then you have Cloud. There they have a little bit of differences, but you can read about each of these images into the documentation. So let's say Debian 11, okay? And we would need to run this command. So Debian 12 here. Okay, so this would essentially create a new container. It would download the image. It would create an LVM volume for us because we created an instantiated incus with LVM. And now it is copying, extracting the image that has been just downloaded into the new volume that is created in this. Now, LXD4, let's go to LXD4. LXD4. So here we want to see LVS. And what you would see is that in terms of storage configuration, currently we have a TINPO here, and that is created, and nothing else. So now we would wait until this actually finishes. This usually takes a little bit longer the first time, and it's normal. Keep in mind, this machine is only with normal hard drives, no SSDs there, so it's not fast. Sorry. I should have put a few SSDs for the demo. At certain point, we'll see the new volume. Yeah, it's being created right now when the image is extracting. So as soon as it finishes, it would do this. Okay, so while we wait, let's continue to the next thing, and usually the important things are how we would manage this. And one thing that you may have noticed that I did was, okay, perfect. We just saw how the volume was created, and as soon as the volume was created, we have our container, LXCOS, incus LS. And now we have our DevOps Days 1 container. But before I dig into that, LXD1HCX. So what I did was LXC at and LXD4. But what is that? Because at does not exist as a command in neither LXD or LXC or incus. I'm used to LXC. As I said, I started with that many years ago, and LXC has a command called LXC-attach. So I just tweaked the bash completion of the LXD command to have AT, and that is actually doing LXC exec LXD4 bin bash. So I'm essentially executing a command inside the container, and because I just don't want to write all of that, I just tweaked a little bit the bash completion to have the AT. Okay, so here you go. We're inside our container. What we can see is that this is our container, and if I go up into that, this is our virtual machine, okay? So this is a virtual machine. This is a little bit different than an actual container, and I'll explain why. So this is the host machine that we have here. It has containers running, okay? So we can see we have this container here, which is, no, this is the host node, sorry. We have the virtual machines, the QEMU processes, and then we have a container running that is the stats container. I intentionally started this container just for you to see the difference in how you're seeing virtual machines and containers. You can interact with these processes. You can kill these processes of the container. You can kill, theoretically and practically, a process within a virtual machine without entering into that virtual machine. But the GDB food that you need to have to do that is enormous. Okay, now that's it, and I just want also to show you a smaller container that has only a handful of processes compared to a container that has a lot of other things in it. Okay, so that was getting inside the virtual machine. Now, incus at this does not exist, right? Here, this is in our testing container, so exec, and this would be DevOps days 1, and bin bash. Yep, almost. Okay. Now I'm in this container, and I would just show you within the virtual machine itself, we have this container, and what is not seen is actually the bash process that you have just created. So that bash process is coming from here. It is important because when you do PS, here you're not seeing that, you're seeing the bash process, but if you do W, you would not see any login because there was no any login. You just started this process inside of the machine. The same goes for the virtual machine. There won't be a login. There would be a process, and it would be under the incus agent. But there won't be any login. So tracing that in terms of login accountability is something that is left as an exercise to the reader. Okay, so this is how you get in. And why is it important? Because our container doesn't, I set it with automatic networking, so it has networking. Generally mine don't have networking, and when I start them, they don't have networking. When they're running, and you can clearly see this here, when they're running, initially they do not have networking. I have to start it inside of the container the way I have decided to do that. Okay, so if you're just running this for the first time, you would notice that there is no SSH here. We don't have SSH. We cannot SSH directly, even though there is networking. So executing a command inside of the container is the only thing that you can do to enter for the first time, unless you have created your own image from which you have already SSH set up, your keys set up, and whatever else you need to. So this is the getting into our container. The next thing are basic things like start, stop, restart are important things here. So getting out of here, incus ls, we have DevOps days there. Incus stop, this guy here. Now you would notice that it takes a little bit of time to stop it like this. So we will start it again, okay? And we can immediately attach to it, no problem. And now, what if we have a process that doesn't want to die for some reason inside the container? Or we just don't want to wait for the operating system to finish correctly? We can force that thing to shut down, and that would be with stop this. It takes a little bit less time, and it's obviously faster. The restart is the same thing, so there's no need for me to show it. Exec I showed. Now, let's say we have a database there, and we just want to create a backup of this database. Because we have selected a storage that allows us to create snapshots, we can just create a snapshot of that storage. But before we execute this command, I just want to show you a few things. So incus storage. You would notice that all of the incus commands have relatively good help. And I generally don't remember any of these commands. I type the command, I see the help, I move forward. This allows me to do even complex things without very big delays in trying to remember something or Googling all the time how I should be doing something. So storage here has a few things. List and show are the two things that I want to show first. So you would expect that this would work all the time in storage list. But let's go here on the host node, LXD storage list. Where did I do that? It should be here. Usually it gives an error.
Down the instance that you didn't restart it now.
No, this is the host node, and on the host node, as you can see, the name of the storage is not default, it's local, and by default it wasn't searching for it, so I generally needed to add local here because it's needed for the destination here. Oh, that was for volumes, sorry. Let's see that. So we have this storage, and we would do volume there. And for volume, the help here tells us that we can do things like listing all the volumes. And we would say list, and it immediately gives us help instead of what you are expecting, the list of the volumes. And the same goes for my host node. Yeah. So this would just not show everything. So in order for us to see the list, we need to provide the name of our storage. So list, and here the pool, our pool here. Because we intentionally created this with different pool name instead of default. I generally do this because I have multiple storages at home, and I want to be able to identify between the different storages that I have. So if you have a larger setup, this is actually very important during setup to not do the default, because default would be your local probably, but what if your local is actually a network iSCSI from somewhere, right? That's not very good for description. So list here, and now we see the image here, and we have one image and one container. So we have two things here. Let's do the same thing, but here on Gandalf, and here this is called local. Here we have multiple images, in this case 2 images, and we have containers, and we have these custom storage volumes here. The custom things are additional storage that I have added to each of the containers, because when I created the containers, I didn't specify size. When we created that DevOps 1 container, does anybody know what size it is? I don't know. We'll have to check that. So we have this volume list, and now what we want to do is volume info, and then it would also need our pool and the volume. I'm showing directly the help because otherwise you may not notice this. So we have store 1, and our container is DevOps days. Okay, so store 1 and DevOps days 1. Okay. What? Yeah. Did I misspelled store? Okay. Pool volume type, yeah, and it was container. Yeah, sorry, I forgot the type. So here we see this information, and show would give us a little bit more. show would give us a YAML setup of this volume. It would tell us what file system it is using, what options, mount options are added, which containers are actually using this. And in this case, we have DevOps Days 1, and this is only one instance that is using this. You may have a volume that is used by multiple instances, like a shared directory or a distributed file system that is connected to multiple containers. That's not a problem. You would see this. And again, we don't know what the size of this thing is still. So when we enter incus exec DevOps Days 1 bin bash, when we enter into this container, yeah, I stopped it. Yeah. Incus start DevOps Days 1. So when we enter into this, we now see what the size of the image is, and that's 10 gigabytes. It may be enough for initial start, but probably it's not enough for normal production environment. So we may need to increase that or add additional storage. Increasing in this case, you can do it by leveraging local normal LVM commands or leveraging incus for that. Let's look how this is done with the normal LVM commands, and just to see how we can use tools that we are used to for managing LVM and controlling this underneath incus. So incus would not know that, what happened. So in this case, LVS, we need to increase this, which is in the volume group store 1. So LV resize plus, let's say, 10 gigabytes to store 1, this image. Yeah, I should have done -R to do the resize to FS immediately. Forgot about that. So now what we have to do is resize to FS. But resize to FS needs the device. So in this case, this device is mounted, and we actually have it here. Dev store 1 containers. So this guy, resize to FS. Okay, and let's get inside the container. Huh?
You did not, if you go back to your command you did earlier, the store is having an E too much.
Oh, yeah. Okay, so now I can just run with the -R. Thank you. Thank you for noticing that. Okay, so this runs the LV resize, and it also runs resize to FS. If you forget the resize to FS, it's not a big deal. You can still run the resize to FS from the host machine without a problem. The issue that you would have is if you have run this container for a long time, let's say a year or two, and there are parts of the file system that are partially corrupted. You would essentially need to stop this container and do a file system check and then resize it, because resize to FS cannot do everything for you. Okay, with different file systems, this works in a different way in terms of the back end of it, but generally, it's on the front end, it's the same thing. So now when we enter, we should see 20 gigabytes. Yes, thank you very much. Okay, so next thing, yeah, resizing. Oh yeah, after resizing, I want to do the snapshots first, but I forgot. Okay, so again, I started with the help here, so I can come here, incus, storage, volume, and we have this nice snapshot thingy here. Snapshot. And it tells us, okay, we have certain flags. We would not dig into the flags right now, but we want to create a thing. So, create. And it tells us, okay, in which pool you want to do it, which volume, and what would be the name of the snapshot. So let's do that. We are in store 1. The volume is DevOps days 1, and snap on. Yeah, container. Oh, that's the main one. Yeah, there was a trick around this. Let's go outside again of the machine into the host node and store LXCOS. So what I want to show, yes, not here in LXC4 at LXD4. So here, what I can do is, because I know that this is the volume, I can just create a snapshot with the LVM tools on the host node again. Or for the custom images, I can create a snapshot. LXC here, storage volume local, list local. So here I have these custom LXD 1, 2, 3, 4 store. So let's create a snapshot there. So snapshot, create local LXD1 store 1 store, okay, and snap on. Snapshot. Yep. LVS, and let's see snap on. Where is snap on? Here is it. So we have a snapshot now. We can copy that snapshot somewhere else, whatever we want. Normal LVM snapshots, you can directly work with those without dealing with LXD directly. If you want to do it with LXD, you can, but you can also not deal with that. Snapshots are created, so list is an important thing. And now list would need again a snapshot list. Yes, pool and volume, yes. Okay, so we have here local, and the volume is LXD1 store, and we have one snapshot. We can delete that snapshot, we can I think rename it, yes, and we can restore it. So obviously all functionality that you would generally need is available there. Then the next thing that you would generally need with containers is confine them in with limits, and usually these limits are CPU, memory, I/O, things that you would want to do, like processes, and it's very easy to do so. Right now we don't have any limits on these machines, so what's happening is that we have a lot of resources. Let's look at LXD4, cat, proc, CPU info. We actually have how many here? Only one CPU for the virtual machine. But if we go into LXC attach stats, cat, proc, CPU info, and we would notice that this container has 24 cores, and that's not because I have given it 24 cores, it's because I haven't given any limits on this. So this one core that we have in the virtual machine would not allow us easily to add more cores and limit into that. So let's add more cores to these virtual machines. And this is LXC here, and the container, the virtual machine is LXD1, and let's put 10 cores here. Okay, so this actually requires two things. One is to expand the control group that is controlling the virtual machine, and then tell the virtual machine that there are new CPUs there to use. Now, when we go here, okay, let's attach again to LXD4, cat proc CPU info, and now, it did not do that automatically. Okay. I'll reboot it just for a second. Sorry. It should have done it through the agent to do this. So since this is a virtual machine, they do not boot as fast as your containers. Okay, wait a little bit. And it should come with 10 CPUs. Oops. Cat proc CPU info. No, why?
I think you did it on the...
Oh yeah, LXD1, not 4. Ah, thank you. Not noticing basic things. Sorry. Okay, so let's attach again to this guy. No, it's still 0, LXD4. Let's reboot it again. But let's, before that, show LXD4. So the config is the one thing that combines all the information you have for your container from LXD, and it gives you a lot of information like interfaces from the host, from inside the container, and in information about the image that was used, which volume it has, in which pool, and where is the root device? It should be here too. Okay, the important thing about the root device is this profiles default. I'll explain this in a bit. But before that, here we have, we should also see the limits. Yes, the limits for the CPU. Okay, so this was rebooted, I think, yes. Oh no, I did not reboot it. Okay, we'll wait a little bit to log in again. In the meantime, the next thing is set processes. Processes on virtual machines do not matter, but processes on containers matter a lot. And I'll tell you why. Because if you are running kernels that are before 4.0, you have a limit of, and that is not a theoretical limit, that is a hard limit of about 25,000 processes on the machine. When you go over that limit, the scheduler is just so slow that the whole machine freezes for longer periods of time. You would not easily debug this. So on newer kernels than 4, you generally have better scalability, but by better meaning about 56,000 processes. I'm not conjuring these numbers out. I have tested that many processes on my machines to verify these numbers. After 56,000, around 57,000, again, the machine becomes extremely sluggish, even if the processes themselves are very basic things that are not doing network or memory a lot. But allowing your containers to grow many processes is always a problem. So you don't want to do that. And in order to prevent this, you can just set the limit. Okay, let's see what happened with our LXD4 here. Does it have 10 now? Yes, it has 10. Okay, generally you can add hot add CPUs, memory, and network interfaces into a virtual machine. I don't know why this is not working right now on Incus. I know that years ago I have done that with KVM, not very hard. So QEMU itself supports that. So probably a feature request for them. Okay, but a reboot does this. Now we're in the container, Incus LS. We should have our DevOps days here. Yes, it is here. So we will start that. DevOps days. Okay. Somebody started it. Thank you. So LXC, Incus exec DevOps days 1 bin bash. And now, cat proc CPU info. Now you can see that we have 9 cores here. So because we haven't set any limit, it has all the cores. Now let's limit that. I'll copy again the command. We'll go here, DevOps days 1. Getting into here, cat proc. 6 cores. No reboots, nothing. This is why I started this workshop by saying there is flexibility that you can get with containers that you cannot simply get from your virtual machines. The important thing here is if you have dev instances or client instances that temporarily need a little bit more resources, you have a very, very easy way to do that without changing a lot of things, without rebooting. Adding memory is the same thing. The only problem is actually removing memory. Now, let me explain this part. Let's say that you have a container that currently has allocated 8 gigabytes of memory, and it has a memory limit of 12 gigabytes. And you decide that you would say that this container should have only 6 gigabytes of memory. As soon as you hit the enter here on your limits command, so with the memory to 6 gigabytes, you would be triggering an out-of-memory situation within that container, but not immediately. This would happen on the next memory allocation that is requested within a process in that container. And depending on how you have configured your kernel, you may either have situations where the kernel would go through all processes of the machine, only the processes within the control group, or directly kill the allocating process. So this depends. If you have configured the kernel to kill the allocating process, and this is it in CTL here, grab -A, yes. So if you select this, the issue is that this may not be the process that is going to be killed may not be the process that is eating the most memory. And if you do not have kill allocating task, this would trigger the full OM process, meaning that the kernel has to go through all processes. And if you have 20,000 processes, this is a lot of work for the kernel to identify which process is eating the most memory and kill that. Also, if you have configured this dump tasks, if you have a container with many processes, this would think about 10,000 processes. The kernel would iterate over 10,000 lines and start printing that on the serial terminal. The serial terminal of the kernel is the slowest interface of the kernel. They're really the slowest one, which slows down the machine significantly because you are printing on a very slow interface. That's it. You can have sluggish host machine because of these things. Now, panic on OM, definitely not for container-based machines. Okay, let's move forward with the next thing. Copy. We would copy from one machine to another machine, but we first need to expose our other machine on the network. So let's do that. And okay, before we do that, there are two things that I want to mention here. When we are copying containers, you need to worry about both storage and networking. The storage part is, if you want Incus to copy the storage, this would take time. If you are copying, let's say, 2-3 terabytes of data of a container, it takes a lot of time, especially if you're doing it on over 1 gigabit. You can, however, use cluster file systems or distributed file systems, where with clustered file systems, this means that you can mount the same file system from one host node to another host node, and essentially you would not be needing to copy anything. You would just need to essentially create the new container on the new machine and start it, and then stopping it on the other container. This way, the processes on both host nodes have access to the same files at the same time. Now, this is only the file system. If you run, for example, 2 MySQL simultaneously on a single directory, you have a problem, and I hope you know that. So this is where you need to be conscious about how you're doing your storage copying. Then the networking has another problem, and that is you're essentially creating containers on another physical machine. That physical machine may not be in the same VLAN as the first one, may not have access to the same networking as the first one, so you may need to essentially reconfigure also routers, firewalls, switches to make sure that access is available there. And on larger networks where you share everything into one segment, usually it's a good idea to, from the containers, as soon as you migrate to the other node, to run rping to make sure that you update the MAC address tables of any switches on the network. We'll execute this copy last. Now let's look into profiles. So why do we need profiles? What you saw was essentially initially you create a container without knowing what this container would have in terms of limits, in terms of storage, in terms of devices as a whole. Profiles allow you to control this, and you have one default profile. You use that profile to set up the defaults for launching new containers. But you can add multiple profiles. Let's say I want to have a profile that would be the same as the previous ones, but it would have more memory, or it would have less memory, or something that is different than the default. Then you would go with the next one, a new profile that would have more, let's say, devices, more network devices. You can then, when you are launching a container, so we did incus launch. When we were launching the container, we just use this type of command. We can provide a YAML configuration of the profile, or we can just specify a profile to use with the -p and the name of the profile for the new instance. This is very helpful because this way you configure everything in your profile, and every new container that you create is with that profile. One thing that my friend Antonio here showed me was you can use multiple profiles for a single container. This way, what you're doing is you may create your container with the default profile, but then have a profile that adds 2 GB of memory limit, then another profile that adds 6 CPU cores limit, then another profile that says process limits, IO limits, and so on. So your profiles can stack up. So the important thing is they should not include the same information. Like you cannot have 2 profiles that are giving both different storage, or that are giving different limits. Okay, so let's look into profiles. LXD profile list. Incus. And let's show this profile, show default. So our default profile here tells us, okay, the containers would have one network device. It would be using bridge interface. This interface would be a network card. We would have one root device. It would be from our store one pool. It would be type disk, not directory. So we are creating a logical volume. And currently this is used by only this instance. If we have multiple instances, we will see that multiple instances are using this. Profile list here, we have again only one thing, but let's say show default, what you are seeing is that all of our containers are now using this profile. You can stack up, as I said, a few profiles. So let's create one profile here, LXC profile, create T1, yeah, incus. And let's see this. It doesn't have anything. So what we will do is essentially make sure that in this profile we have the limit that we want, for example. So DevOps days 1, this would be here. So show config, show DevOps days 1. Okay, and here we have limits that have to be applied. So incus profile. And here we need to set limits CPU equals to 6. And we need to say, sorry, this is for T1. Okay, so let's show T1 again. Now we have CPU limits 6. Now when we are creating our container the next time, so launch DevOps days 2, that would be with also our default and also our T1. And now let's see what this would be. Sorry. Okay. You don't see the limits here. Let's see. However, we are seeing 2 profiles. So the limit is no longer in the container, it is in our profile. And both profiles are there to help us achieve what we want here. Okay, we can also do stuff like manage this with an API. Do you guys want to do this? Because we need to set it up, and it takes a little bit of time because we need to set up the certificates. Okay, let's do that. I have linked the documentation directly here because I haven't done that in a while. Okay, so this is the documentation for the API. The authentication is entirely with certificates. So it's basic. But on the other hand, we have another issue. We have to expose, if we want to create real certificates, we can use Let's Encrypt. But in order to use Let's Encrypt, what's proposed from the documentation in Incus is install HA proxy and configure that before you're exposing LXD over port 80. So where was this? I think it was in the main documentation here, and we scroll down. In the main documentation, in the top, there was remote authentication. Yes. Yay. Okay. So adding trusted certificate to the server is actually pretty easy, but the issue is that you would need to create the certificate. On the other hand, one thing that you can do is make sure that you can add a remote IP directly as a valid authenticated remote. So let's go with first the certificate. So we would need to execute this command. Okay. It was a link, sorry. In order to add the certificate, we would need to have the certificate from somewhere. So before that, there should be an HA proxy set up somewhere regarding this. Yeah, here is the HA proxy setup. So we would set up HA proxy here. Yay. At least we have it on a package. Oh, yeah. Our resolve is not working. Okay, it's working now. Okay. We'll need Let's Encrypt in a bit, but first let's do the HA proxy. So we'll copy this, we'll paste it here. Incus node. We have only one. Everything seems to be in order. Let's verify that Incus is listening on this port. No, it's not listening. No, it's not listening. So the next thing is to configure networking here, because we haven't exposed this. So Incus config show. Okay, and there was something for the networking, I think. Give me a second. Yeah, network. No, this is for the host network. Admin or cluster? Nope, not this. So it should be here in config. Okay, I don't remember what it was. Yes, I don't remember it. Config. We need to set the network, which was. Sorry.
We don't have to do it if it's too complicated.
No, it's not too complicated. It just takes like 5-10 minutes to do that. Sorry, but the idea was to do it live. This is why I didn't. I initially started with no exposed to network. So yes, I forgot to check this. LXD config network interface, I believe. It's in the documentation. No. Thursday, the remote ad. Okay. Set, yes, that thing. Okay. I told you it's in the documentation. It's a good documentation. Very good, actually. So, npt. Now we should have LXD here. Yes, Incus is here. So it's listening over the network. I told you it's easy. It doesn't take that much. So the next thing, going back to our HA proxy, yeah, we need Let's Encrypt. Acme domain. Okay, yes, a few things I forgot to edit in the HA config. Where the Acme stuff? Oh, yeah. This is, sorry, the Incus configuration for Acme. Yeah. This here. Domain. Okay, so we have a live domain, so it's not a problem. We need to set it up. And that's Acme. It's this guy. Okay, equals LXD 4, 1h.cx. Okay, we set that. Email, let's give you email equals this. Okay, and then we have okay. Let's add this guy. Yeah, we need to set up a few things in order for it to work. Okay, so we set up those. This should be automatically changed, but let's set it. Okay, so incus config show. We have this information for the server. Let's go back and see. Have I forgotten something? I don't think so. Okay, okay, and where's the? No, there was a command for this. Okay, we may not do it actually. Okay, we'll do it without the certificates. I want the certificates, but okay, we'll do it without remote name, remote address. Okay, let's add incus, what was it? Remote add LXD1, and that is 10.2.3.1. Okay, yes, trust token. Huh? Where is it? Oh, yeah. So on LXD1, now I have to connect there. LXD1, LXD1. Here I need to add a trust token, trust. Yeah. Trust add certificate, no, trust add the token, right? So remote add, okay. LX incus remote trust 10.2.3.4. Add, okay, and remote would be LXD4, IP 10.2.3.4. Okay. No, I'm missing one command. Remote trust token, yes, dash token. No. So you see the token here. We just need to generate the token for this remote, and it should. Oh yeah, dash token afterwards. So this is it token, dash token, or just token? Yeah, read the documentation at some point. Using tokens, so add name, IP address. Okay, let's add the token this way. What would be the token? It's there what I'm missing. Okay. The remote is added 2 times. This should be IP. Let's do this with IP 10.2.3.4. And yeah, token. Let's put this there and remove this. Note that there was the trust for the token. Yep. Trust. Yeah.
Finally, we can I have another question.
Yes.
Can you type of auto-scaling? Is the solution like vertical or horizontal auto-scaling, or there's none?
Is there what to scaling?
Auto-scaling.
Auto-scaling. No, there is no auto-scaling, but there are a few scripts out there from people that do this. Generally, they are very basic. If you want auto-scaling, I suggest that you go through the control groups on the host machine and verify the usage. And because I have built auto-scaling systems exactly based on LXD, so what you can do is simply go through the usage within the containers, within the control groups on the host node, look at 5-minute increments of these values, and decide when to add additional resources every 5 minutes. Not less, because if you start doing that less, any small spike is incrementing the resources in the containers. For downscale, that's a different issue. For CPU, it's pretty easy. You can just say how much CPU is utilized within the control group and then downscale when it's no longer used. However, if it depends on how you have configured your limits. If the limits are per core, you need to make sure that a full core is available now, free, to remove that core, because as soon as you remove it, you would starve the rest of the process in the container. For the memory, as I told you, out of memory is a problem. So what you want to make sure is that if you had a container, let's say, with 8 gigabytes of memory, and it is currently using 7 gigabytes of memory, you cannot simply remove 1 gigabyte. You want to have at least 25% of your increment available down. So if you want to remove 1 gigabyte, you need to make sure that 250 gigabytes would be available after you remove this gigabyte. So these are important considerations there. On I/O, I would suggest not to do auto-scaling. I/O should be something that you control very tightly, because this is impacting all of your containers very hard. Memory and CPU are not that impactful as I/O. Other questions? Yes?
Yes, I have a question about what package do you recommend to use for UI managing or instance and
Oh, UI, I have tried this LXD matrix, I believe it was. Give me a second. Yes, LXD Mosaic. I'm not a fan of UIs, so I cannot suggest anything. This is the only thing that I have ever tried for UI. Generally, I just collect information from my containers in Victoria metrics. This is a different version of Prometheus, think of it like that. And then in Grafana, I'm displaying the metrics. I'm not needing a UI interface where I want to click with a mouse. Usually I do that on the command line. And if you want a UI, the API actually provides you with that flexibility to just do whatever you want. This way you can implement it in your infrastructure. Let's say you have your custom interface for clients or custom interface for your developers. You can just add one curl call and you would be done with it. the full setup, as you have seen, with installing Incas, running a container, and preparing everything would probably take you like half an hour. Compare this with Kubernetes. Now, that would be half a month at best. So yes, this is scalability and UI not available as a package within LXD, but probably something I can, at least for the scalability thing, I can add a few things in LXD, because the maintainers are very nice guys. They accept any contributions, and it's a good idea. I have experience. I can do that. Anything else? Okay. Thank you for listening to me for so long.